To implement curly with let type, our examples show that we needed two new kinds of values, a variant v and a constructor v. Constructor v again is for a constructor like apple or banana, something that can be applied to a value to create a variant value. So when we apply constructor v apple to num v1, then we're going to get a variant v tagged with apple and the num v1. Right? So this curly value applied to this curly value will give us this other curly value. On the expression side, we have let type and type case. And these are big forms compared to what we've had before just because there are a lot of pieces. In a let type, we have the name of the type that we're defining and the two different variants and the type for each variant and then the body expression. So that's what we see here, a body expression and the type name, and then tag 1 and type 1 and tag 2 and type 2. That corresponds to tag 1, type 1, tag 2, type 2. Type case has a similar number of pieces. We have the type name at the top. We have the expression that I'm calling the test expression that we're going to go to one case or the other. Each case has three parts: a tag, a name of a variable that's bound to the field of the variant, and an expression for the result. So that's what we have here: a tag, a name, and the right-hand side expression for each of those two clauses. And also to represent a type name, like the symbol that we put here, like fruit or animal, then we'll have a defined t that can be used as a type. So putting those pieces together now with the interp function, let's look at the case of interpreting let type because it's actually pretty straightforward for the interp. When we have let type, fruit, apple, banana, and so on, the main work is evaluating the body expression. But that body expression can use these variant constructors, apple and banana. So that's what let type needs to do. It needs to add apple and banana to the environment. And we see that here. So here we are adding apple with to be a constructor with the same type apple, same tag apple, and we bind banana to be a constructor for the tag banana. We extend the environment in that way, and then we evaluate the body expression here. That's all for let type. Let's look at the application side though. So when we do actually create, we bind apple to a constructor v, and here we have an appy form. Right? This is applying apple to the argument 10. So that means appy needs to not only deal with closures, but also deal with constructors. If we're applying a constructor, like apple, to its argument, then the result is a variant v with that same tag that's from the constructor. Right? So apple will be a constructor v here with quote apple as its tag. So we make a quote apple variant with the result of interpreting the 10 here in that example to be the value inside the variant. And then there's type case. Let's look at type case in the context of this example. Type case of a fruit, apple, 10, and so on. So the first thing that type case needs to do is interp that test expression. That is, it needs to interp the expression that's right here, in this case apple 10. And when it does that, hopefully you get a variant v back that you can match against these cases. If you don't get a variant v, maybe someone wrote +1, 7 here, then when we do a type case on value of the interp, it won't be a variant v, it'll be an else, and we'll complain. Of course, our type system should reject putting +1, 10 here, but our interpreter for now is just going to accommodate all possible cases. So hopefully we get a variant v back. And when we get a variant v, hopefully the tag on that variant matches one of the ones we've declared. So tag 1 is the declared tag for this first case, apple, right? That comes out of our type case here. So tag 1 corresponds to apple, tag 2 corresponds to banana. We take the result of this expression as a variant v and compare its tag against those declared tags. If we don't find a match, then that means there's been some other sort of mix-up. There was a type case on fruit, and an animal that was tagged bear was returned instead. So we'll have interp complain, but if it does find a match, then it should evaluate the corresponding expression on the right-hand side. So in this case, we want to evaluate just this a. If there were a banana there in the test expression, we would evaluate the second case. So that's why we've got an interp on the right-hand side here. As we interp this expression, then it should be able to refer to this variable here, which stands for the field inside of the variant value. So here is our variant value with its tag, and val here is the field's value. So that's what we want to put in the environment. We bind the name that was given with the clause here, a name like A corresponds to N1, and we bind it to that value. And we have box of sum here because we're inside our interpreter that also has letrec. So we need boxes and options to deal with letrec. And the second clause is just like the first one, right? We interp the right-hand side for the second clause if that was the matching tag, and in that case we bind n2, which corresponds to the variable name